Here we're looking at example 4 from our 2.4, number 2 set of notes. We're told to write an equation of a line that's passing through A, this point, and is parallel with this segment LT. Well, we see that L is at 2, 5, and T is at 8, -1. And from those 2 points, we can go ahead and construct the slope between those 2 points. Because again, if we just connected these two, we have some segment, which is basically almost some line. And we can go ahead and construct the equation of that line. So we're going to go ahead and find the slope first of this. So we end up then with -1 minus 5, so subtracting the y's, over 8 minus 2. So it looks like we end up with -6 on top over 6. So then it looks like our slope comes out to be -1. Now keep in mind, it says write an equation of a line that goes through this point A that is also parallel. And that's really key, that this line is going to be parallel to that segment LT. So we should see something looking relatively like that, where they end up with the exact same slope that we're going to go ahead and use. So we're going to go ahead and use -1 as that same slope. So plugging them into our point slope formula, we have y minus y1 is equal to m times x minus x1. Again, that's point slope. We end up then with this point representing our x1, y1. And throwing them in there, we end up then with y minus our y1, here he is, 7, equals our slope, it's -1, times x minus x1. Here's our x1, 6. And from here, we're just basically simplifying things. So we would distribute this negative in first, end up with y minus 7 is equal to -1x plus 6. And then lastly, we're just going to add that 7 over. So we end up then with y is equal to -1x plus 13. And so this would be our equation. Notice that it is passing through that point and is parallel with this other one, this other segment LT. Again, though, that is example 4 from our 2.4, number 2 set of notes.